Good morning, students. Myself, Vijay Shankar from BC Department, Chapter Engineering College. So today we are going to discuss about the sampling theorem. So very important topic in the third unit, sampling theorem. In the yesterday class also, we discussed about the sampling. So what is the statement and how we can get the time domain signal x delta of t is equal to x of t into sum of n is equal to minus infinite to infinite delta t of n into ts. Got it, my students? And convert this into the time domain function to the frequency domain function by using the trigonometric Fourier series. Okay. So what is the statement? Sampling theorem statement is a signal which is band limited to FM hertz. A signal which is band limited to FM hertz can be completely recovered from its samples. If the samples are at a rate of Fs is greater than or equal to F2FM. Okay. The same thing here also, the continuous time signal can be completely represented in its samples and is recovered back if the sampling frequency Fs is greater than or equal to 2 omega, or the 2 omega here, to W. W is EFM, the maximum frequency present in the signal. Okay, take the x of t signal and sample the signal with the delta of t minus n into ts. Multiply the two functions. X of t is equal to x of t is equal to x delta xs of t is equal to, let us take it's a delta. X of t is multiplied with the sum of n is equal to minus infinite to infinite delta of n minus ts, or the n minus ts, t minus n into ts. Otherwise, x delta of t is equal to the combining of the signal x of t, the sum of n is equal to minus infinite to infinite delta of t minus n into ts. Got it, Madison? After the sampling, you can combine the two signals x of t and the impulse train. We got this expression. Yes, here x delta of t is equal to sum of n is equal to minus infinite to infinite delta of t minus n into ts and x of t. The t is represented the multiplying the equation by the x of n into ts, since the width of this impulse is the x delta of t approaches to the 0. Or you can the continuous time signal x of t also. Okay, you can keep the x of t at the t is equal to ts. X of t is at instant t is equal to ts. Now how the time domain signal, whatever here the time domain signal x delta of t, convert the x of f is equal to fs into sum of n is equal to minus infinite to infinite delta of f minus n into ts. This is by using the trigonometric Fourier series. Okay, my dear students. Now let us take, I'll explain the whiteboard. The time domain signal x delta of t is equal to, listen carefully, my dear students, this is a proof of the sampling theorem. You got the x delta of t is equal to, this is an impulse instantaneous sampling. Okay, there's a different types of techniques out there. In this, the instantaneous sampling, the flat top is there. Okay, different types. In that types, it is a instantaneous sampling. x delta of t is equal to sum of n is equal to minus infinite to infinite, x of t delta of or delta s of t minus n into ts into the x of t. Actually, the x of t I'm representing as a x n into ts. Okay. The trigonometric Fourier series, trigonometric according to the trigonometric Fourier series, the equation x of t is equal to, or the x of t, here I'm taking in terms of delta t s of t is equal to delta t s of t is equal to, let us take the a naught by 2 plus sum of n is equal to 1 to infinite an cos n omega s into t plus sum of n is equal to 1 to infinite bn into sin n omega s into t. This is the equation for the trigonometric Fourier series having coefficients a naught, an, and the b. Got it, my dear friends? So x delta of t is equal to x delta of t is equal to is a function of x of t into the sampled version x delta ts of t. X delta of t is equal to. In this, a naught is equal to, what is a naught? 2 by ts, 2 by ts, the integral minus t s by 2 by ts by 2 x of t into dt, x of t into dt. See, for the impulse train, the 0 is a magnitude is a 1, and at the ts is magnitude is a 1. That is nothing but a delta t minus ts when n is equal to 1 here is a delta of t, and 2ts, its magnitude is 1, nothing but the delta of t minus 2ts, and so on, as a variable of the t here. And similarly, in the left hand side also it is shifted minus ts, its magnitude is a 1, and delta of t plus ts and minus 2ts, its magnitude is a 1, and delta of t plus 2ts. T plus 2ts. This is a sum of the total function, sum of the n is equal to minus infinite delta of t minus n into ts. This impulse train. Now I am taking the a naught is equal to in between of ts by 2 the ts by 2. Here the minus ts by 2. So I am representing this a minus ts by 2. And here also the ts by 2. The range of in between minus ts by 2 the ts by 2. This is the x of t signal. This is an impulse train signal. What is the value here? The delta function is nothing but 1 only. Okay. In between these ranges, we have only the one value, that is at t is equal to 0 only. Got it, my dear friends? So the a naught becomes a naught is equal to 2 by ts. 2 by ts, this total function in between of the minus ts by to the ts by 2, we have only the values of 1. So 1 is equal to 2s by ts. 2 by ts. So a naught we got. A naught is equal to 2 by ts. Got it, my dear friends? How we got this one? Because in the range here, the x of t signal is a delta function. The second thing, an is equal. What is the an is equal to? The 2 by ts integral minus ts by to the ts by 2 minus ts by to the ts by 2, the x of t, and multiplying with the cos n omega s into t dt. Okay. Here also we are taking the in the between of range minus ts by to the ts by 2 only. In that the delta function x of t is a delta of t is a 1, and having see the an is equal to, I will write here the 2 by ts, x of t is a delta of t, and cos n omega s into t dt. What is the n here? N is equal to, you can take as the 0 value, because having only the 0. N into ts, n into ts, here the n is there, the value 1, n is equal to 2, n is equal to minus 1, and n is equal to minus 2. So here I am taking the n is equal to 0, cos 0. What is the cos 0 is equal to 1? Cos 0 is equal to 1. The delta t function is also the 1. So an is equal to, the same thing we'll get the 2 by ts. Is when n is equal to 0. When n is equal to 0. Means delta t minus n into ts and delta t minus n into ts. When n is equal to 0, it becomes of a delta of t, and cos n, the value the cos is 0. When substituting the n is equal to 0, the value is a 1. So an is equal to 2 by ts. And next thing, the bn. What is a bn value? The bn is equal. Equation is 2 by ts integral minus ts by to the ts by 2. Listen carefully, my dear students. It's a very important. Definitely, it is in the, you'll get in the external, the 7 marks or the 8 marks question. Integral minus ts by to the ts by 2, the x of t into sine n omega st into d. Now, here also we are applying the integral in between of the minus ts by to the ts by 2, having only the value at t is equal to 0. Got it, my dear friends? So the 2 by ts, it is a delta of t, is a value is a 1, and got the 0 when n is equal to 0 here. When n is equal to 0, what is the sign? Sine 0 is a 0. So Pn is equal to, we got the Pn is equal to 0. Pn is equal to 0. We got all the terms of coefficients. So A naught is a 2 by ts, An is a 2 by ts, and Pn is equal to 0. Substitute this A naught, An, Pn values in the delta ts. Delta ts. Delta ts of t is equal to, what is the A naught? We got the 2 by ts. 2 by ts into 1 by 2 plus sum of n is equal to 1 to infinite an. An we got the 2 by ts and cos n omega st plus sum of n is equal to 1 to infinite bn. Bn value is 0 into sine n omega s into t. Simplify this function x delta of t, or rewrite the function x delta ts of t is equal to, the 2 to get cancelled, 1 by ts plus sum of n is equal to 1 to infinite 2 by ts into cos n omega s into t. Got it, my students? So we got the delta ts of t is equal to 1 by ts plus sum of n is equal to infinite 2 by ts into cos n omega s into t. I can substitute this function in this x delta of t. X delta of t is equal to x of t into this simple strain. The x delta of t is as a trigonometric Fourier series function. Okay, now the x delta of t is equal to x of t multiplying with the x delta ts of t as an impulse strain here in terms of the trigonometric Fourier series I'm writing. X delta ts of t, we got 1 by ts plus sum of n is equal to 1 to infinite 2 by ts cos n omega s into t. And rewrite this function x delta of t is equal to x of t by the ts plus and sum of n is equal to 1 to n is equal to 1 to infinite x of t by ts. 2 you can write it outside, 2 into the cos n omega s into t. Okay, my dear students. And now we can apply the Fourier transformation on both sides. The Fourier transformation on both sides. Okay. I will explain the next page. Listen carefully. The x delta of t is equal to, we got x of t by ts plus 2 into sum of n is equal to 1 to infinite x of t by ts cos n omega s into t. Okay. X delta of t is equal to 1 by ts into x of t plus 2 into sum of n is equal to 1 to infinite. Here also I am writing the ts directly. So 2 by ts into x of t cos n omega s into t dt. What is a cos in terms of the exponential value? We know the cos n omega s into t is equal to e power j omega s into t plus e power j omega s into t and e power minus j omega s into t pi 2 is a cos omega s into t, not the cos n, my dear students. This is a cos omega s into t. And you can rewrite this function that is equal to the x of t by ts, x of t by ts plus 2 by ts. You can expand when n is equal to 1 here. N is equal to 1, the x of t into cos omega s into t. There is no any dt, my dear students, here. Sorry. It's a sum only. Plus x of t into cos 2 omega s into t, and so on. Got it? Because it is a starts from the n is equal to 1 to infinite. I wrote the cos omega s into t is equal to, and similarly cos 2 omega s into t is equal to e power j 2 omega s into t plus e power minus j omega 2 into omega s into t by 2. Got it, Martis? Substitute this function, cos function, in x delta of t. X delta of t is equal to x of t by ts. Listen carefully, my dear students. What I am writing, the every equation is very important. 2 by ts multiplying with the x of t. Here you can see the cos omega s into t. I am substituting as e power j omega s into t plus e power minus j omega s into t by 2. Plus x of t into the another function cos 2 omega s into t. That is e power j 2 omega s into t plus e power minus j 2 omega s into t by 2 plus so on. Okay, my dear friends. So now again simplify the function, the x of t by the ts plus 2 by ts whole multiply with the x of t into e power j omega s into t plus x of t e power minus j omega s into t plus x of t e power j 2 omega s into t plus x of t e power minus j 2 omega s into t plus up to so on. Is here the 2 by 2 is there, by 2 is there. Totally, I am writing here the 2 and 2 to get cancelled. Got it, my students? All the functions there is a by 2 is there. I am writing here the 2 and 2 to get cancelled. So x delta of t is equal to. Now apply the Fourier transformation on both sides. The Fourier transformation of x delta of t is equal to, so 1 by ts into, it's a Fourier transformation of x of t plus 1 by ts into 1 by ts into, so whole multiplying here, the Fourier transformation of x of t e power j omega s into t plus the Fourier transformation of x of t e power minus j omega s into t plus the remaining two terms also, the Fourier transformation of x of t e power j 2 omega s into t plus the Fourier transformation of x of t e power minus j 2 omega s into t and so on. So what is the Fourier transformation of x delta of t? It is the x delta of omega. What is the Fourier transformation of x of t? X of omega. So because the x of t, the Fourier transformation is, what is the Fourier transformation? X of omega. Or it is also the x of f. Okay, in terms of the angular frequency and in terms of the normal frequency. Okay. You'll get the x of t, its a Fourier transformation is x of f also. Got it, Martin? So now, individually you can take the terms and apply the Fourier transformation. We'll explain the next page. In the left hand side, the Fourier transformation of x delta of t is x delta of f is equal to 1 by ts into 1 by ts into x. Fourier transformation of x of t is x of f and plus 1 by ts into internally the Fourier transformation of x of t into e power minus. What is the Fourier transformation of f of t? Integral minus infinite to infinite. The x of t, you see here, this is a x function. X of t e power j omega s into t. E power j omega s into t. This total function is x of t signal into e power minus j omega t dt. Got it, my students? And for the next term, the integral minus infinite to infinite, the x of t e power minus j omega s into t is total signal x of t, the e power minus j omega t dt plus another third term is there, integral minus infinite to infinite x of t e power j 2 omega s into t is a total function into e power minus j omega t dt. Got it, my students? Plus the last term here, the integral minus infinite to infinite x of t into e power minus j 2 omega s into t is a total function e power minus omega into t dt plus up to so on. What it matters? That is equal to 1 by ts into x of f plus 1 by ts into, you see here, you can write this function as integral minus infinite to infinite x of t into e power, both the bases are the same. You can write the, add the power e power minus j omega minus omega s into t dt plus the integral minus infinite to infinite x of t into e power minus j. Here the omega s and the omega both are the minus, so omega plus omega s into t dt plus integral minus infinite to infinite, this is the third term, the x of t, the exponential base is the same, so take the minus j is a common, omega, here the 2 omega s is there, so minus 2 omega s into t dt, and the fourth term, integral minus infinite to infinite x of t e power minus j omega plus 2 omega s into t dt and so on. What it matters? Observe here, by using frequency shift property, we know the integral minus infinite to infinite x of t power minus j omega t dt is x of omega actually. Instead of omega, here the omega minus omega s. Therefore, the x delta of f is equal to x of f whole divided by the ts plus 1 by ts and multiplying it is the x of omega minus omega s. I am writing in the normal frequency x of f minus fs plus, and here the omega plus omega. See, it is a omega minus omega s and it is a omega plus omega s. So the second term becomes x of f plus fs. Or otherwise, it's the omega x of omega plus omega s. Got it, my friends? And the third term plus, in the third term also you can see it is a omega minus 2 omega s, x of f minus 2fs. Got it, my friends? Plus, here I am applying by using the frequency shift property. The frequency shift property actually it is a e power minus j omega t, nothing but it is x of omega. Instead of omega, here omega minus omega s. I am writing in the normal frequency. And the fourth term, x of f, see the fourth term also omega plus 2s. Got it? F plus 2fs and so on. Got it, my friends? So the x delta of f is equal to, see the two terms, there is a common term is there, 1 by ts. Write the function x of f plus x of f minus fs see, I will write in the order. See, for n is equal to, but so on, I am taking this as so on, plus x of f plus 2fs plus x of f plus fs plus, I'm writing here the x of f is there, x of f plus, here another term is there, we have the x of f minus fs plus x of f minus 2fs and so on. Okay, all the terms we got. X of f we got x of f minus fs, x of f minus 2fs. Before that is x of f plus 2fs and x of f plus 2fs and so on. So this total function which is multiplied by the 1 by ts, we can write as x delta of f is equal to 1 by ts into sum of n is equal to minus infinite to infinite x of f minus n into fs. Got it, my students? So very, very important. Finally, we got it is after applying the Fourier transformation. When n is equal to, see, we got the function. When n is equal to, so on, when n is equal to minus 2. When n is equal to minus 2, it becomes of x of f plus 2fs. When n is equal to minus 1, we'll get x of f plus fs. When n is equal to 0, when n is equal to 0, the x of f only. When n is equal to 1, the x of f minus fs. When n is equal to 2, x of f minus 2fs. So for the time domain function, See, we take the time domain function x delta of t is equal to sum of n is equal to minus infinite to infinite delta ts t minus n into ts x of n into ts as this function. Applying the Fourier transformation of this function, we got x of f is equal to 1 by ts is equal to sum of n is equal to minus infinite to infinite x of f minus n into fs. Otherwise, you can write as therefore x delta of f is equal to, what is the 1 by ts? Nothing but fs. Sum of n is equal to minus infinite to infinite x of f minus n into fs. After applying Fourier transformation for the function x delta of t, for the function x delta of t is equal to sum of n is equal to minus infinite to infinite delta of t minus n into ts, that is delta ts x of n into ts. Okay, for this time domain function, you can apply the Fourier transformation. We got x delta of f is equal to fs into sum of n is equal to minus infinite to infinite x of f minus n into fs. Got it, my dear students? See whether we get the same equation or not, we can verify. See, in this, by taking of x delta of t is equal to sum of n is equal to minus infinite to infinite delta of t minus n into ts x of n into ts. Apply the Fourier transformation. Fourier transformation, we got x delta of f is equal to, see here, x delta of f is equal to fs into sum of n is equal to minus infinite to infinite x of f minus n into fs. Okay, the same equation we got. What we derived in this x delta of f is equal to fs, sum of n is equal to minus infinite to infinite x of f minus n into fs. Got it, my dear students? And how we can recover? By using this equation, the Fourier transformation equation, to get the original signal. Okay, we'll discuss in the later.